Okay, so here I am trying to um, complete slide 10, the quadratic relationship slide in my physics textbook. So hopefully you found your way here. You could go to Google Slides or Google Drive and search for my physics textbook. Um, you could go to Canvas and look for my physics textbook in the modules. You go to slide 10. Um, First thing we're going to do is we're going to want to add a graph. Now this is the graph that we just made of the dry ice sliding down the ramp. Um, if you need to find your way to the Desmos graph, one way to do it would be to go to the modules, look for the acceleration lab, and if you go here, you'll see there's a link to the Desmos graph. Going there should take you to the graph. Um, I don't have exactly that access, but here's my graph. Um, so I'm going to take a screenshot, Command Shift, boom, screenshot, and I'm going to go back to my physics textbook. I'm going to add my screenshot by choosing Insert, Image, Upload from Computer. Now, on my computer, it stores on the desktop. On yours, it may be different. You may have to hunt for it. Hopefully you've had some practice with this because we've been messing with screenshots a bit this year. I have a lot. Um, so I got to find the one I just took. This may take a moment here. It's not that one. It's that one. I'm going to open it. There I am looking kind of goofy in the corner of my graph. Oh well. Um, Now, I don't want all this other stuff. I really don't want even me, but a little bit of me is going to be left behind. I want to double click on the graph and it lets me uh, mess with the edges. So right in the middle of the left, I'm going to pull it in until I just have graph. Up in the top here, I'm going to pull this in until I just have graph. I don't need to mess with the right or the bottom. I click somewhere to the edge and boom, most of it goes away. Now, I'm going to put this in the upper right, but I need to shrink it a bunch. So I'll shrink it down, kind of tuck it in here. I don't mind if it takes up a little extra space. I really want this graph to be as big as it can be so that I can really see it, see that nice quadratic relating time and distance. Beautiful. Now, I'm going to jump back here for just a sec. I'm going to notice that my equation for this graph is y equals 56x squared. So I'm going to start under the equation line with y equals 56x squared. Now, that is the specific equation for my specific graph. Not terribly informative, but if you've done the little run through of what does 56 mean in this equation, you should be aware that this also is translatable as, I'm going to change some letters. I'm going to change all the letters here. Remember, y on the y-axis is actually distance. So I'm going to make that d equals, and that 56 isn't really 56. It is 1/2 of the acceleration of that puck. So I'm going to type 1/2 times, and I'm going to use a for acceleration, times, now remember our x-axis is actually our time axis. I'm going to use t for the x-axis, and it is squared still. So d equals 1/2 at squared, or 1/2 times a times t squared. The phenomenon we investigated to get this was a dry ice puck sliding down a ramp. We will get this from any object accelerated by gravity or any other constant acceleration. What does it mean? I interpret that as like, let's turn our equation into an English sentence. So d, or distance, or the distance the puck, or the object, goes, is stands in for equals, 1/2 of stands in for times, right here anyway, of the acceleration, which is some constant. In the case of this particular thing, it's whatever twice 56 is, like 112 centimeters per second squared. 1/2 of the acceleration multiplied by, I don't want to get confused between mentioning times as a multiplication and time as the time. So the distance the object goes, 1/2 of the acceleration multiplied by the time it travels squared, or multiplied by itself. So there's our sentence, our equation as a sentence, which I like. Our claim sentence is what we would write if we were writing our conclusion paragraph. So I'm going to say, I'm going to refer to the relationship between time and distance, time being the independent variable, distance being the dependent variable. So I'm going to say there is a quadratic, how do I spell quadratic relationship between the time and well, I'll make it for the specific case of our lab, between the time the puck slid and the distance it slid. There we go. That is our claim sentence. I don't much care about the data table, quite honestly. If we had a nice, really clean, really simple data table, that would be cool, but this is good. There you go.